All right, so the first question, thing that we want to review is what it means to be similar. So what does it mean for two figures to be similar?
For the angles to be congruent and the sides to be proportional to each other.
All right, so to be similar, there are two requirements. Angles need to be congruent, corresponding angles need to be congruent, and corresponding sides need to be proportional to each other. There has to be some ratio that we call the scale factor, and that kind of describes how much the figure was blown up or shrunken down, right? Both of those must be met for something to be similar. Just one or the other is not good enough. Both of those are requirements for similarity. Question 2 looks at some proportions in an algebraic nature, just kind of how we solve proportions. So the first one given there, x over 6 equals 15 over 18. How do we solve proportions? We could reduce it. If you wanted to, we could reduce down that 15 and 18. If you don't notice that or you just don't want to bother with it, you could just jump right in and start cross multiplying. If you would rather be dealing with some smaller numbers, you could reduce that down. What does 15 over 18 reduce down to?
5 and 6.
Okay, so they both reduce by 3 to give 5, 6. Well, then cross multiplying seems a little bit pointless because what over 6 equals 5 over 6? 5, right? 5 over 6 has to equal 5 over 6. So on that, we don't even really need to cross multiply because if it's something over 6 equals 5 over 6, well, it must be a 5 for those to line up, right?
I see.
The next one doesn't work out quite as neatly. We cannot reduce down the fractions, so we have to solve this by cross multiplying. So when we cross multiply, we're going to multiply diagonally across, so I get 5 times x equals 3 times 14, which is 42. Divide both sides by 5. And you could just leave it right as 42 over 5 unless it's a totally acceptable answer. That's what I usually do because then I divide and I'm done. Or if you want to grab a calculator and divide that out, then you get 8.4, and that's fine too.
So you can leave it as anyone.
You can leave it as a fraction. I actually prefer fractions to decimals. And our last one there says 7 over x plus 2 equals 14 over 6. We could reduce that down, but I'm not going to just for the sake of example and how we would do this. If I cross multiply, 7 times 6 is 42. What do I have to do when I multiply 14 times x plus 2? I have to distribute. So I have to do 14 times the x and 14 times the 2. What do I do next to solve this? Subtract 28 from both sides. And I get 14 equals 14x. That divide by 14. And 1 is x. Any questions on that? The next problem I want to look at is question 3 on the test. And question 3 says, if it is given that 3a equals 7b, then what are some other fractions that we could set up? So what would a over b have to be equal to? Well, if 3a equals 7b is a multiplication, it's not fractions anymore, it must have come from cross multiplying the ratio. So if a over b was 1/2 of that ratio, how would we set up the other stuff so that cross multiplying would give 3a and 7b? 7 over 3. So we know it's enough to be the 3 and the 7, and so figuring out which way they go, we just want to look at cross multiplying. So if I want to end up with 3 times a, then a must have been on the diagonal from 3. Okay. The next one says, what would b over 3 be equal to? And for that, instead of referring back to the original, I refer back to the one that's already fractions and say b over 3. Well, what did that do to that last set of fractions that we set up? And then let's do the same thing for the other side. So what would b over 3 be equal to? A over 7. If b over 3 reads the bottoms of that middle one across, then we should also read the tops across. So b over 3 should equal a over 7, right? And cross multiplying that would still give 3a and 7b. Okay. So we can always check back to that original and cross multiplying. Okay. Questions on that? Number 4 gives us a ratio, or a proportion really, that we're going to assume is true. And then we're asked about some other rearrangements of that and to decide whether or not they are true or false. So we had a lot of properties of proportions, and so what we want to do is see, are the things it gives us here properties of proportions or not? So does xy equal wz?
True.
No.
How do we multiply proportions?
Cross.
We cross multiply them. We can't multiply them up and down or side to side. We have to multiply them on the diagonal. So this does not work. Okay, we are allowed to cross multiply, so we could do like xz and yw. We can multiply on the diagonals, but we can't multiply up and down or side to side. The next one says xw and x over w and y over z. Does that work? How is it related to the original?
You put the top two on the left side and, oh, it's like turn sideways.
Okay, yes, it's like turned sideways. So the top two turned into a fraction, and then the bottom two turned into a fraction in the same direction too. Both of them went left to right, so that works. The next one says x plus y over y equals w plus z over z. That is true. It is, when we learned about our properties of proportions, I said probably the weirdest property of proportions. It's just strange. It's not something that we would apply very often to a problem, but it does work that we can add together top and bottom and keep it over the same bottom. That is a property of proportions. That's something we're allowed to do with them. It's just kind of a weird thing to do with them. The next one. How is that related to the original one? It flipped them upside down. Does that work? Yes. We are allowed to flip them upside down as long as we flip them both upside down. And the last one here says x minus y over y, w minus z over z. True or false? True. That one is true. It's a lot like the other one that I said is kind of the weird one. What's different about it? It's subtraction instead of adding. But that property, when we learned the properties of proportions, said that we are allowed to either add or subtract, and it would be true. As long as we're doing the same thing. So we can't like add for one fraction and subtract for the other fraction. But we can add or we can subtract. And either way, that property is true. Questions on any of those properties of proportion? Alright, the next question I want to look at, we're going to skip question 5 on the test and we're going to go on to question 6 on the test. Question 6 gives us two pictures of quadrilaterals. And we are told that these two quadrilaterals are similar to each other. And they're similar kind of in their orientation of the way that they're drawn. So everything is just matching up nicely and neatly. Nothing's flipped over or upside down or backwards. So it's kind of convenient that way. We are asked then to solve for our three missing letters, X, W, and Z, and also for something about an angle. So first we're solving for the missing sides. The first one that we're asked to solve for is W. When we want to solve for a missing piece in similar figures, we need to locate our scale factor. What is going to be the scale factor for these two figures? 5/8. We need to find the corresponding sides that we know information about in each figure. So 5 and 8 are the same side of each figure, and those are the ones where we know numbers instead of knowing letters. So that's going to be the scale factor, and that relationship will hold for any set of corresponding sides. So if I want to solve for W, is W going to go on the bottom or top of the other fraction? Bottom, because it's in the figure with the 8, and 8 was on the bottom, so W is going to go on the bottom. What's going to go on the top of that? 6, because 6 is what matches with the W. You solve this by cross multiplying. So 5W equals 48. Just want to divide out. And you could leave it at that fraction, or you could divide it out and get 9.6. Now when I go to solve for X, is the next thing that we solve for. We go back to the same scale factor, because that scale factor should be true for any set of sides in this, any corresponding set of sides. So if I want to solve for X, is X going to go on the top or the bottom? And what matches with it to go on the bottom? 24. And we're going to cross multiply this, and then you get 8x equals 8 times 24. Oh, I didn't write this down.
116,
Let's see. 20, 10, 120. Was close. Divide by 8, and we get 15.
Someone will do that wrong.
And when I go to find Z, I'm going to set up the same proportion, 5/8, because that's our scale factor, should be true for any matching set of sides. Is Z going to go on top or bottom? Bottom, and what matches with it to go on top? 10. Cross multiply, and we get 80 equals 5Z. Divide by 5, and I get 16 is Z. Questions on how to set up a proportion to solve for a missing piece? The last part of this question says measure of angle D is equal to measure angle blank.
No, it says H.
Oh, well, we're going to say this because that's what I wrote already. We don't know anything about any of these angles, but we do know the figures are similar, which means what about the angles? The corresponding one should be congruent. So what one should be the same as D? H, which I guess on your sheet is actually written the other way, HD, but whatever, I gave the answer before going ahead because I wasn't actually looking at my paper. I was trying to remember the questions. So, but any matching set of angles should be congruent. We don't know how big they are, but we know the matching angles should be congruent because that's part of what it means to be similar. Okay. Questions? All right, the next one I'm going to look at is question 7. Question 7 gives two pictures of triangles, and we're told the triangles are similar. Now, technically, we should probably be told that they're similar in the orientation they're drawn. It doesn't say that; it just says the two triangles are similar. We're going to assume they're similar in the orientation that they're drawn. Otherwise, we really can't solve this. So we're going to assume that what looks like it's corresponding is corresponding. So what would be the scale factor for these two?
14/10.
14/10. And if we're solving For x, how would we set up the other side of this proportion?
X plus 2 over X.
X plus 2 over x minus 3. Okay, the other matching sides in the same direction. So 14 is in the triangle with x plus 2, so those both go on top. We can reduce this down and turn it into 7 over 5 to get a little bit smaller numbers to work with. And then when I cross multiply, we need to be careful to do what? Distribute. So 7x minus 21 and 5x plus 10. What could I do first to solve this equation?
I mean, add 21.
I could add 21. We could actually move any one of those 4 pieces, and it doesn't matter which one. I usually move x's first, but it doesn't matter. We can move any one of those 4 things, and we just want to combine together some stuff that's alike. Then what would I do next? Subtract 5x from both sides. 2x is 31, and how would I finish it out? Divide by 2. And I get x is 15.5 or 15 and a half.
Or 31.
Or 31 over 2. Yes?
Why are the smaller angles on the bottom? Like, minus 14.
It doesn't matter.
Top one is
So you could also set it up 10 over 14, and then you would just have to do the x minus 3 over the x plus 2. It doesn't matter which direction you go as long as you're consistent in doing it.
Okay.
Alright. Now we're going to skip ahead to question 11, which was the second sheet of paper that was passed out. And it's a set of true-false questions.
I don't have a second.
It was like this one.
I got one. She get one.
Alright, on this, we are asked about true or false in terms of some figures being similar. To answer true, we must be able to say that those are always true, not sometimes. If it's just sometimes true, that's actually false. Because true implies always true, that it must happen, not that it could happen. So A says all triangles are similar. That's false. 2 triangles can be similar, but to be similar means all the angles must be the same, and that's not true for all triangles. All triangles don't have all of their angles the same, so that's false.
Is this how you say, like, you don't say rhombuses, you say rhombi?
That's true.
Sweet.
Yes, the plural of rhombus is rhombi. So B says all rhombi are similar. What do we know about a rhombus? It has 4 congruent sides. So, if this is a rhombus, would all other rhombi that I could possibly draw have to be similar to this one?
No.
What could be different?
The angles.
The angles could be different. It could be more tilty, it could be more straight up, and so that wouldn't work out. All the sides will definitely be in proportion because they're all going to be the same. So there will be some scale factor between sides no matter what, but the tiltiness of it could change, so the angles wouldn't have to match, so that is false. C says all squares are similar.
True.
What do we know about a square?
Four squares at the same
Same angles
angle.
and same sides. So all the angles will have to be the same in any squares, and if they're not exactly the same size, there will at least be some relationship between those sides because they're all the same. So that is true. D, all rectangles are similar.
False.
False.
So what do we know about a rectangle?
It's got 90-degree angles.
It has 90-degree angles, but we don't know anything about the sides. So I could draw a rectangle that looks like this. And would every other 90-degree thing have to be similar to that? No. For example, a square, right? Wouldn't work. And a square is a rectangle because it has all 90-degree angles. So that is false. E, all similar triangles are congruent.
False.
Why not?
because you could have a tiny one, which is same angle measures, that's in proportion to a huge one with same
Okay,
angle.
so similar means angles are the same, and congruent angles should also be the same. But similar means sides are in proportion, whereas congruent means sides have to be the same. And they don't have to be the same, they just have to be in proportion to be similar. So that is false. The backwards of that, all congruent triangles are similar. That would be true. What would the ratio be?
1.
1 to 1. F, all regular pentagons are similar. What does it mean for something to be regular?
Same angles, same size.
Same angles and same sides.
True.
So all these are the same, and all those sides are the same. So if I drew another pentagon that also had all angles the same, would those angles have to be the same as these angles?
Yes. Yes.
Yeah, a pentagon has a certain amount of degrees that have to fit inside of it. Just like a triangle, just like a quadrilateral, a pentagon has a certain amount of degrees. It's actually 540 that has to fit inside of a pentagon. So we split that up equally. 108 would be all of our angles, no matter how long the sides are. Okay? And if all the sides are the same in one and all the sides are the same in another, then there would be some proportion to those sides. So that is true.
So
The keyword there is regular.
Is there no such thing as a regular rectangle?
There's no such thing as a regular rectangle. A regular quadrilateral is a square.
Good job, Ethan.
Thanks.
Well, I guess a regular rectangle is a square still, because a square is a rectangle. So, let's see. We're on G. G. All congruent hexagons are similar.
True.
True. All congruent anything should be similar. Right? Congruent hexagons would have to be similar. Congruent pentagons would have to be similar. Congruent polygons. Are all congruent polygons similar?
Yes.
No.
Yes.
What do we know about a polygon?
It has a number of sides.
It has a number of sides.
And it's closed.
So are all congruent polygons similar?
No.
Because they're congruent.
Yes, but you could have like a square and then you could have like an octagon.
There you go. That's the key. Polygon, we don't know how many sides. So they would be similar if they had the same number of sides. They would not be similar if they had a different number of sides. So when we say polygon, we don't know how many sides we're talking about. So we would need to be more specific than that. H. All equilateral triangles are similar.
True.
What do we know about an equilateral triangle?
It's got equal sides.
It has equal sides. Okay. To be similar means two things. It means we need sides and angles. What do we know about the angles of an equilateral triangle?
They have to be 60.
They all have to be 60. If all the sides are the same, all the angles have to be the same, and it all have to be 60. So that is true, that it would work. The final one says all rhombi with congruent consecutive angles. Okay, so a rhombus. What do we know about a rhombus?
4 congruent sides.
4 congruent sides. Congruent consecutive angles would mean that two angles right side by side would have to be the same size. So if this is our rhombus up here and two angles side by side are the same size, how big would those angles have to be?
They would have to be the same.
Have to be
Oh.
90.
They would have to be 90 because a rhombus is a parallelogram. So those would have to be 90, which means that this thing turns into a what?
Square.
Turns
Or
into a
rectangle.
square. And we already said squares are similar.
Square is a
So this works. It's specifically a square, not just a rectangle,
Yeah.
because a rhombus has all its sides the
Yeah.
same.
How about a base tip?
Okay? Alright, so that is what your chapter 7 test would have been like, but now you have it to review for the